So like I was saying before, today is our second day of conics. We're going over an ellipse. Now, there's going to be a lot of vocab at the beginning of this lesson, and I just have to tell it all to you. I know that most of it will go over your head, but just try to bear with me. An ellipse is most commonly known for orbits. Like all planetary orbits are elliptical in shape. It means that they kind of have like an oval pathway to them. Now there are two different types of ellipses. There's a horizontal ellipse and a vertical ellipse. We're going to take a look at the horizontal ellipse first. So if we're looking at this ellipse, there are two axes. There is the major axis, which is the longer axis. And there is the minor axis, which is the shorter axis. Now, if we have our major axis being horizontal, the longer length is horizontal, this is what makes it a horizontal ellipse. Whereas if the major axis, the longer axis is vertical, then it is a vertical ellipse. Now, if we're looking at this ellipse, the horizontal ellipse, half of the major axis is called the semi-major axis, semi meaning half, and that's our A value. So from the center to the vertex, half of the major axis is A, and this is called our semi-major axis. It's half of the major axis. Kind of, yeah. Except it only is on the major axis. The half of the minor axis is actually your B value. It's going to be different from your A value. It is obviously shorter. So B is called our, I should do it in green, I guess. Semi-minor axis. That's okay, Samantha. And because A is on your major axis, it will always be the larger number. A is always going to be your larger number. So if A, the larger number, is under your X term in the equation, this is what makes it a horizontal ellipse. If your larger A value, your larger denominator, is under the Y term, this is what makes it a vertical ellipse. Also notice each ellipse has two foci, they're called plurally, but we have a focus and a focus. These are always going to be on the major axis. And this is actually what gives the elliptical shape. Also notice that the ends of our major axis are called vertices, and the ends of our minor axis are called covertices. The center is still located at HK, and there's one more thing. Oh yes, C. The length from the center to the focus is your C length. Now, there is no position for C in your equation. So most often, you're going to need to solve for C. And the way that you solve for C is by using this kind of variation of the Pythagorean theorem. But instead of it being C squared is equal to A squared plus B squared, it's C squared is equal to A squared minus B squared. So all you have to do to solve for C is just square root A squared minus B squared. This is how you find the distance away from the center the foci is. Okay, so I think that's all of the information I had to impart to you. I know it was a lot. We're going to go over it again as we do these examples. Oh, no, there's a little bit more. So the length of the semi-major axis, remember the semi-major axis is actually your A value. So the length of the major axis is just going to be 2 times A. And the length of the semi-minor axis, remember that's our B value. So our minor axis is just going to be 2 times B. Okay, so let's try it. I know it was a lot of info, but as we go, you'll get the hang of it. Looking at this equation, where or what do you think the H value is? What do you think the H value is in this equation? Anybody at all, because we haven't really done an example yet, so you may not know. Yeah, not quite, Lauren. Yeah, it's 0. Remember, just like in a circle, the H value is subtracted from X, and the K value is subtracted from Y. So in this equation, there is nothing being added or subtracted from X, and nothing being added or subtracted from Y. Meaning, your H value is 0, and what is your K value? Yes, your K value is also 0 because there is nothing added or subtracted from Y. So our K value is also 0. This means that our center is located at 0, 0 for this equation. Now what about our A value? What do you think A is? Yes, Peyton. Yeah, yes, Lauren. Exactly. Remember, A is always the larger denominator. But if we look at our equation, the denominator is not just A. The denominator is A squared. So in this case, 81 is bigger than 16. So that means A squared is equal to 81. So in order to get our A value, we don't just write down 81. To get our A value, we have to square root 81. So the square root of 81 is 9. What do you think our B value is? Yes. Our B value is 4 because the other denominator is 16. So that's what B squared is equal to. So the B value is the square root of 16, or 4. So now, what type of ellipse is this? Vertical or horizontal? Is the bigger denominator under the X or under the Y is the question. The bigger denominator is under the X. Which one had your A value, your bigger value, under the X term? Right. The horizontal has A under the X term. So this example has 81 under the X. That means it is a horizontal ellipse. And we have everything we need to graph this ellipse now. We know our center is at 0, 0. And we know it's a horizontal ellipse. So that means we're going to take our A value and count left and right that many. So from the center, I'm going to count 9 to the left and 9 to the right. This creates our horizontal major axis, where these are our vertices. Vertex, vertex. To get the minor axis, you use your B value and you count that many up and down. So I'm going to count 4 up and 4 down. These are my co-vertices. And then you just connect these. And you create your horizontal ellipse. It's horizontal because the longer axis is horizontal. So if you graph your ellipse and you know it's a horizontal ellipse and then it ends up turning out looking like this, it means that you graphed it wrong. Okay, so now we're just going to write down where these vertices and covertices are. My vertices are at 9, 0, and negative 9, 0. My covertices are at 4, 0, 4, and 0, negative 4. Now the hardest part about this is finding the foci. Remember, we can't identify the C value, the foci value, in our equation. Instead, we have to solve for C to know where our foci are located. We solve for C by using the formula square root of a squared minus b squared. A squared is 81, b squared is 16. 81 minus 16 is 65. And we have to ask ourselves, can 65 be reduced at all? Can I reduce that square root? Is there a perfect square you can pull out of this 65? Is there a perfect square factor that goes into 65? There is not. No, there is not. Now, you may be asking, okay, well, how the heck does that give us our coordinate point, our foci's coordinates? Well, 65 is actually like 8.5. So that means that from our center, we go 8.5 to get to our foci. And we go 8.5 the other direction to get to our foci. We know that the foci are on the major axis. So we have the same k value as the center. We have the same y value as the center. That doesn't change. Our y value is 0 for both of these points. But we go in the positive direction of square root of 65, and we also go in the negative direction, square root of 65. So our foci are located at plus and minus square root of 65, comma 0. Another way to think of this is by using a formula. If it is a horizontal ellipse, you write the coordinates of your foci, I should say, hold on, are located at h. You take your h value and you add or subtract your c, and the k value stays the same. If it is instead a vertical ellipse, to find the foci, this time the h stays the same, and k is what you're adding or subtracting c from. Any questions so far? All right, so let's go ahead and try the second one. This one hopefully will come a little bit easier because we already did an example. So what is our h value here? Let's do Jalen. What is our h value? Our h value, remember, is always subtracted from our x value. So here h is just a positive 4. What is our k value, Kate? Yes, exactly, Abby. Yes. Kate, is Kate not here? It's okay. All right. So yes, k is always being subtracted from y, so our k value is a negative 3, meaning our center is 4, negative 3. Okay, so What is our A value? Let's do Isabella. What is our A value? So you're close, Isabella. I know on the previous one it was the A was under the first term, but remember, the A value is always the bigger denominator. It's always determined by the bigger denominator. So here, 4 is not the bigger one. 25 is. So this 25 is A squared. So what is A? It's not erasing. Yes. A is the square root of 25, or 5. What is the B value? Let's do Lauren. Lauren Moore. The first one. Yes, because if this side is our A, that means that this denominator has to be determined by our B. So then we just square root 4, and you're right, we get 2. Good. So, knowing these A and B values, is our ellipse vertical or horizontal, Samantha? Is our ellipse vertical or horizontal? Yes, it is vertical because the larger A value there is under our Y terms, making it a vertical ellipse. So we now have everything we need to graph this. We already graphed our center. We know it's a vertical ellipse. What that means is I'm going to take my A value, and instead of counting left and right like I did previously, I'm going to take my A value and count up and down because that A value determines the major axis, which is vertical. So I'm going to, from my center, count up 5. 1, 2, 3, 4, 5. And down 5. 1, 2, 3, 4, 5. And then I take my B and I count left and right to get my minor axis. So from my center, I'm going to count left 2, right 2. And I should, once I have graphed all of these points, I should have a vertical ellipse, which I do. If you graph these points and you end up with this, clearly that is not a vertical ellipse, so you did something wrong. You did it backwards. So my vertices are at 4, 2, and 4, -8. And my covertices are located at 2, -3, and 6, -3. Now, how do I go about finding out where my foci are located, David? What should I do to find my foci? David going once. David going twice. Okay, let's do Dawson. What do I have to do to figure out where my foci are located? Exactly, yes, good. So we need to solve for C by taking A squared minus B squared and the square root of it. So our a squared is 25, our b squared is 4, 25 minus 24 is 21. And can I pull a perfect square out of 21? Let's go with Ava. Can I pull a perfect square out of 21, Ava? Oh, Ava is literally not here. So let's do Lindsay. Lindsay is also literally not here. Okay, so anybody, can we pull a perfect square out of 21? No, we cannot. There is no perfect square that goes into 21, so this is our C value. Now, because this is vertical, it means that our foci are on that vertical major axis. So the square root of 21 is really close to just a little bit over 4. So from my center, I'm going to go up a little bit over 4 and down a little bit over 4 to get my foci. And because it's a vertical ellipse, it means it's going to have the same K value as the center this time. I'm sorry, the same H value as the center. So our H value here for the center is 4. So the foci are going to have an X value of 4. And then you take the K value of the center, which is -3, and you both add and subtract your C, which is square root of 21. Again, I wrote that formula up above, so you don't have to memorize it. It's written right next to, hopefully you wrote it down right here next to our vertical ellipse. Okay, all I did was I knew that if this is our major axis, I knew that those foci have the same X value as the center. So both of those foci have an X value of 4. To get the Y value of the foci, you take the same K value as the center, -3, and you add and subtract your C value. Any questions there? Okay. So now we're going to do 2 more examples. We may not have time to graph example 4. I didn't have time to graph it for first period. But we're going to look at example 3, and then we're going to graph it. Oh, can you show the equation one more time? Sure. So if it's a horizontal ellipse, to find the foci, we use this formula. If it's a vertical ellipse, we use this formula here. So now looking at example 3. This does not look like the other ellipses that we've looked at so far. This is actually an ellipse written in the general equation form. What we've been looking at before is ellipses in standard form. So what we need to do in order to know how to graph this is we need to put this into standard form. Now, when there are no, there's just x squared and y squared, there's no plane x and plane y, this is actually really super easy to put in standard form. All you have to do is get the constant to equal 1. Because if you notice, ellipses in standard form are always set equal to 1. 1, 1, and 1. So to get this equation in standard form, we just have to get that right-hand side to equal 1. How can we do this? How can we get the right to equal 1? So we could subtract 1 and 43. However, that would place a constant on the left-hand side. And all of our equations for ellipses and standard forms don't have a constant on the left. So that would, yeah. Yes, we divide by 144. If we divide everything by 144, it will get the right to equal 1, and that's what we want. So the right-hand side equals 1, and then I just divide each variable separately. So 4 over 144 actually simplifies down to 36. So we have x squared over 36 plus 36 over 144 actually simplifies down to 4. And now it's an equation that we can graph easily. So what I'm going to do to graph this one is I'm just going to bring the equation down so it's easier for us to look and graph. Okay, so in this equation of an ellipse, what is our center point? Ariel. Let's do Ariel. She's not here. Okay. Let's then do Aubrey. Where's our center? So remember, yes, exactly, Aubrey. Remember, h and k are subtracted from x and y respectively. So if there's nothing being subtracted from x, that means our h value is 0. And if there's nothing being subtracted or added from y, that means our k value is 0. So our center is 0, 0. Very good. What is our a value, Josh Strickland? Okay, so remember that our a value is always determined by the bigger denominator. So which one is bigger, 36 or 4? So that's what hey, I picked pink. That's what a squared is equal to. So if a squared is equal to 36, what is a actually? Yes, exactly. All we do is we square root that denominator and it gives us our a value. Okay, so I've gotten through everybody. If you haven't answered in the chat and you didn't hear your name, most likely you're marked absent. Just a heads up. Okay, so what is our b value? Anybody? If you are thinking you might be in danger of being marked absent, I would try to get an answer in here quickly before the end of class. Like either the first or second person answer. But yes, our b squared value is equal to 4. So to get our b value, we just square root 4 and we get 2. Now knowing this, is this a vertical or horizontal ellipse? Yeah. It is horizontal. Meaning from the center, we're going to count left and right to get our major axis. We use 6, our a value, to count our major axis. So from the center, I'm going to count 6 to the left and 6 to the right. And then to get my minor axis, I use my b value to count up 2, down 2. And I have created my ellipse. Ooh, that's a crappily drawn ellipse. I don't know why I can't draw this. Okay. So my vertices are located at 6, 0 and negative 6, 0. My co-vertices are located at 0, 2, 0, negative 2. And just like before, to find my foci, you do c is equal to the square root of a squared minus b squared. Our a squared term is 36 minus b squared, which is 4. So that is 32. Is there a perfect square that goes into 32? Is there a perfect square that goes into 32? That is a factor of 32. So yes, 32 can be split into 16 and 2, and the square root of 16 is 4. So the square root of 32 simplifies down to 4 square root 2. Now, this is a horizontal ellipse. It's going to have the same, in this case, y value as the center, because our foci are located. Now, what is 4 square root 2? What is that close to? Where's my calculator? 4 square root 2 is like a little over 5.5. So from the center, 1, 2, 3, 4, 5, it's right about there. So both of those points have the same k value as the center, 0, and I both add and subtract my c value from my center's h value, which was also 0. My semi-major axis, remember, that's just your a value. So our semi-major axis is 6, and our semi-minor axis is just b or 2. Any questions on this one? Okay, so now for the last part, we're just going to put this into standard form and then be done. Who knows how we can convert this general equation into a standard equation? What do you think we have to do in order to know how to graph this and get it into standard form? Yeah, that's the first step. That's the first step in what I'm trying to get you to tell me. What did we do to convert a circle into standard form last class? Yes, just like we did with a circle, to get an ellipse into standard form, we have to complete the square twice. Once for the x's and once for the y's. That's why we group the x's, group the y's, and move the 59 to the other side as our first step. So that's what I'm going to do. I'm going to group the x's, and I'm going to group the y's. And I'm going to move that 59 to the other side by adding it over. Now, there is something that's different in an ellipse versus a circle. This elliptical equation has coefficients on our squared terms. When we are trying to complete the square, we cannot have coefficients on our squared terms. So there's an extra step we have to perform to get the coefficient off of the squared terms. What we have to do is we have to basically pull the a term out of both of the variables. So on my x squared, on my x quadratic, I need to pull 25 out of both of my x terms. I'm pulling that GCF. I'm not pulling, I know that the GCF is technically 25x, but I'm leaving the x's alone. I'm just pulling that constant a value out. So 25x squared divided by 25 is just x squared. 50x divided by 25 is 2x. And I must remember to leave a space to complete my square. I do the exact same thing for the y values. I need to pull out the GCF, or the a value. So I'm going to divide a 4 out of both of my y terms. I'm dividing that a value of 4 out of both terms, and I get y squared minus 4. And I need to leave a space to complete my square. And whatever, I must remember that if I left this 2 spaces on the left, I must also leave 2 spaces to be added in on the right. Last class I ran out of room too here. Let's try to squeeze this together. Blue and then a purple. All right. So just now this step is just like we did for the circle complete the square. What value needs to be added in to my x quadratic to complete the square? Remember, if you haven't, yes, Peyton. Remember, if you haven't answered a question as of yet, and you haven't answered in the chat at all, you haven't heard your name called, you at this point are marked absent. Okay, and we find that value we're adding in, remember, by doing b divided by 2 squared. So in this x quadratic, our b value is 2. 2 divided by 2 is 1. 1 squared is 1. So we're adding in 1 here. Now, what is happening to that 1 actually? It's not just a 1 actually. Yes, Peyton. The 1 is actually being multiplied by that GCF we pulled out by 25. So I didn't just add in 1. What I added in was 1 times 25. So that's what needs to be added in on the right-hand side is plus 25 times 1. What about for the y quadratic? What needs to be added in to complete the square for the y's? Remember, it's the same. We find this number the same way we just found the x add-in. Yes, good job, guys. Yes, 4. Because our b value this time is a negative 4. Negative 4 divided by 2 is negative 2. Negative 2 squared is a positive 4. Now, am I just going to put plus 4 on the right as well? What should I put on the right, actually? Right, yes, 16, because what's happening to that 4? It's being multiplied by another 4 in front. This 4. So I have to do 4 times 4, or 16. Now all of these numbers added together actually equal 100. And I need to finish completing my squares for both the x's and the y's. So I need to pull down the GCF I pulled out of the x's, 25. And I need to complete the square for the x's. And I pull down the GCF I pulled out of the y's. And I need to complete the square for the y's. Now, what do I write down to complete the square for the x quadratic? How does that factor into a perfect square? Remember, there's a little trick I told you to get the number inside of the perfect square. You write down your variable, which in this case is an x, and then what do you do to get this number? Yes, you take your b, which is 2, and you just divide it by 2. So our complete the square for the x quadratic is actually just x plus 1 squared. What about for the y quadratic? How do I complete the square here? What does y squared minus 4y plus 4 factor into? Remember, the little trick still works. What should I write down? Yes. You write down your variable, which is a y, and then you take your b and you divide by 2. So I have successfully completed the square for both the x quadratic and y quadratic. However, I am not yet in standard form for an ellipse because it is not set equal to 1. So what should I do to set this whole equation equal to 1? Divide by 100. Yes, divide everything by 100. 25 over 100 means that the x term's denominator simplifies down to a 4. And 4 over 100 means that the y's denominator simplifies down to 25. And 100 divided by 100 is 1. So here, our center is located at -1, 2. Our a value is 5. Our b value is 2. That means that this is a vertical ellipse. And I can now easily graph this. Are there any questions? Any questions about completing this square, converting into standard form? This is standard form of an ellipse.